Alright guys, let's go ahead and do some review here. I'll go ahead and do the even ones, leave the odds for you. Every even problem I'm doing is just like the odd one before it. So here we're taking a square root of a negative number. When you take the square root of a negative number, it's not a real number, it's an imaginary number. And so what we do is we take the negative out and we put an I in the front to symbolize that this is not a real number, this is an imaginary number. And then from there, we go ahead and simplify the square root like we normally would. So first of all, we're going to split up the 294 and the m to the third. The m is m times m times m. 294, we're going to start splitting it up by division. So I know that 2 goes in there 147. I think 3 goes into that, if I'm not mistaken. 3 goes into there 49 times. And then I think 7 goes into that 7 times 7. And so just looking at the end of our branches, you don't look at the other ones because they got split up. We have these values. And so I've got an I, I've got a 2, I've got a 3, I've got a 7, and 3 m's. And square roots tell us to look for numbers that are repeated, like 7 times 7. And for each pair, you can write that number on the outside and cross the pair off. So I can also take out an m. And so this one would be 7i m, and then 6 on the inside and m on the inside. All right, so that's how you simplify square roots with negatives in them. Let's go ahead and take a look at number 4. We're going to multiply this. Now that I looks like a variable, but remember, it's not a variable. That's actually, I is an imaginary number. The imaginary number is -1. Now we're going to be multiplying these together. And in the process, we're going to see an I squared. And it's important to remember that I squared is equal to a real number, -1. So I is the square root of -1, but I squared is -1. All right, so let's go ahead and multiply these together using our box method here. All right, so I've got -10. I've got 35i, 10i, and -35i squared. These can combine together to make 45i. This is equal to -1. And so when I multiply that by the -35, it becomes a +35. And then we can combine these two together because they're both just real numbers. And so -10 plus 35 is 25. My final answer then would be 25 plus 45i. All right, so remember that I is the square root of -1. And also remember that when you have a fraction, mathematicians don't like having square roots on the bottom. I won't go into why right now, but they don't. And so we want to get rid of them. The way that you get a square root like I off of the bottom is you multiply it by itself, which you're allowed to do so long as you also multiply the top. So the top now will be 2i, and the bottom will be 10i squared. And as we mentioned on the last page, I squared is equal to -1. And so I've got 2i over -10, and we can reduce 2 over 10 to be 1 over 5. Okay? So the main thing I want you guys to know is this. The rest of it is just simplifying fractions. All right, let's go ahead and move on to number 7. We're going to be adding to, these are called complex numbers, by the way. When you have a real number combined with an imaginary number, that's called a complex number. What I'm doing right now is I'm adding 2 complex numbers. If you want to add 2 complex numbers, you just need to combine the real numbers together and the imaginary numbers together, and you're done. Now, if you ever have a subtraction sign here, don't forget you do need to distribute it before you begin combining. Let's go ahead and take a look at number 9. We want to solve this equation. So the first thing we want to do when you're solving a square root equation is you want to get rid of the numbers that are outside of the square root. Okay? So if you ever have a number in front of your square root like this, you're going to divide it. If you ever have a number that is in front of your square root like this, then you're going to do the opposite of whatever this is. So if it's plus, you'll subtract. If it's subtraction, you'll add it. Okay? The same thing can be like this instead, where they have it at the end. You're still going to do the opposite, though, to both sides of your equation. So in this case, since I have a number in front of my square root, I'm going to divide both sides by a negative 10. And that leaves me with a positive 10. Now, just so you guys know, let's just say this was a negative right now. That would be no solution, because a square root cannot equal a negative number like that. All right, but we don't have a negative, so we can keep going. The next step is to get rid of the square root, and you do that by squaring both sides, or raising both sides to the second power. Last thing you want to do is get p by itself. In this case, to get rid of the 2, you just multiply both sides, and we have our final answer there. All right, number 11. They want us to graph this function. First of all, to graph a square root function, this number and this number combined make up your starting point. But you have to remember to do the opposite of this number, so it's actually negative 2. But we'll call that our starting point. So I'm going to start at negative 2, positive 4. After that, I gave you guys a chart a while back, and it looked like this. How am I supposed to remember that, Mr. Bailey? Well, in all honesty, I don't really expect you to remember that. That's why I'm giving you a video. But it's in your notes, and if you choose to use notes on a quiz or a test, then that's an option too. On this chart, though, we talked about how the shape of the graph is basically determined by the A and the B value, whether they're positive or negative. They all have a starting point. If both A and B are positive, it looks like this. If only A is negative, then it looks like this. If B is negative, then it looks like this. If both of them are negative, then it looks like that. Okay? One way that I remember it is I remember the A tells me to go up or down. The B tells me to go right or left. So, like in this case, my B is 1 and my A is negative. So since my A is negative, that means I'm going to go down. And since my B is positive, I'm going to go right. So this graph will go down and to the right. That's how I remember it. Or you can just look at the table. All right. Use the information provided to write this equation in vertex form. All right. Just a warning to you guys. There's a lot of steps to this. If you want to see the steps, then I would encourage you to go back to your, I think it was Unit 7 notes, and look for the lesson titled Completing the Square. There's a lot of steps involved there. So if you guys want to pull up those steps and use those to follow along as I go through this, it might be helpful to you. All right, so step 1 when completing the square is to add this number to the other side. Before I go any further, let me tell you what our goal is. We want to rewrite this in vertex form. So this is what's called standard form of a quadratic. Vertex form looks like this. So my goal is I want to rewrite this equation so it's in vertex form instead of standard form. And the steps I'm giving you is the process you go through to get there. All right, so the first step is to add the constant number to the other side. The next step is to factor out the leading coefficient, the -1. I'm going to divide that out of both of these. So if I divide both of those by a -1, I would have this. The next step is a really strange step. We're going to create a new number. And that new number comes about in a two-step process. First of all, you take half of the middle number, which is 8, and then you're going to square it. 8 to the second power is 64. That's called completing the square. Now, we want to fix the balance. We have an equation here, and if you add something on one side, then you're going to have to add something to the other side to keep the equation balanced. Now, you might be thinking, oh, well, Mr. Bailey, isn't it just, we added 64, so don't we just put 64 on the other side? Well, not necessarily. Let me show you. I'm going to add a new number on this side to keep my equation balanced because we added a 64 on the other side. But it's not always going to be the same number. In fact, often it won't be. The reason why is because by putting a 64 here, we actually put a number that's being multiplied by -1. Everything in the parentheses is multiplied by -1. So what you're going to do is you're going to multiply these first, and whatever you get, that's what you're going to put here. So -1 times 64 is actually a -64, not a +64. All right. Now the next step is we're going to factor this. Now you could use the box method, but since this is a special kind of trinomial that is created when we do this process here called completing the square, we can use a shortcut. The shortcut is this. It's always going to look like this. The only thing we need to figure out is what number goes here. And that will always be half of that number there, so it's going to be 8. On this side, we can combine the 71 and the -64, and we're going to get 7. The last step is to go ahead and subtract this 7 back over here like so. And now I've got it in vertex form. So that's a lot of steps. But that is the process of changing a quadratic equation from standard form into vertex form. Like I said, I had the steps written out in words on your notes for completing the square back in Unit 7. So if you want to use those on the day of the test, it might be helpful to you. Go back and find those. Now we're going to go ahead and graph a quadratic equation that's in vertex form. If I take this number and put them together, not forgetting to do the opposite sign of this one, then I get the vertex of my quadratic function. So I'm going to have a vertex at -6, +6, which is right here. The next thing we're going to do is we're going to look at our a. If the a value is positive, you have a happy face parabola, and if it's negative, you have a sad face. Well, in this case, my a is positive, so I have a happy face, so my parabola would look something like that. And that's it for that one. Kind of nice. Number 17, we want to solve this equation using the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This is the a, this is the b, and this is the c. And all we have to do is plug it in and simplify. Now, you don't have to do this first step that I'm about to do, but it is pretty helpful. Notice that these numbers are pretty big, first of all. But notice also they can all be divided by something. What can 12, 12, and 4 all be divided by? They can all be divided by 4, which I'm allowed to do since I'm doing it to both sides of the equation, and I end up with this instead. So I'm not going to use these numbers anymore. I'm going to use 3 for A, negative 3 for B, and C for 1. Now, if you just want to use the original numbers, you can. But if you can reduce, I would encourage you to do that because it makes doing the quadratic formula a lot easier. All right, so quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the b goes here, the a goes here, the c goes here. The first thing I do in simplifying these is I simplify these 4 chunks. Next, I take care of my square root. Now, when you have a negative, you take it out and you put an I there. And so this becomes 3 plus or minus I root 3 over 6. Now, just so you guys know, you might have to break down your square root and take out some pairs like we did on the first example problem from this worksheet. Sometimes also, you can simplify this by reducing. Like, let's say, for instance, I had like a 3 here. Well, so long as you have a number here, here, and here, you can reduce all of those. For instance, I could divide all of them by 3 and reduce it. But since I don't have a 3 there, then I only have a 1, which means that there's nothing I can reduce by. So this is my final answer. Another thing to keep in mind is if you ever have a negative on the bottom like this, just go ahead and take it and put it up here. That's how the answer will look on the multiple choice test. All right, let's go ahead and do one more problem here. We're going to graph this quadratic expression. Now this is also a quadratic. We graphed a quadratic earlier, but this one requires a little bit more work than graphing when you're in vertex form. Graphing in standard form, we're going to follow some pretty similar steps. We're going to find our vertex, and then after that, we're going to decide if our A is positive or negative. If it's positive, it's a happy face. If it's negative, it's a sad face. But the problem with this is that the vertex is not as obvious. When you're in vertex form, you can just look at it and see it. For standard form like this one, you have to find it. You need to find your x and your y. To find the x part of the vertex, you're going to use this formula, negative b over 2a. B is 8, a is negative 2. If I simplify that, I end up with 2 as a final answer. To find your y value, you're going to take this number and plug it in to the original problem, 2x squared plus 8x minus 11. And then you're going to simplify. That's 4. And 4 times 2 is 8. So it'll be negative 8 plus 16 minus 11. Putting those three things together, we end up with negative 3. So my vertex is 2, negative 3. Now we're ready to graph it. There's my vertex, 2, negative 3. And since my A value is negative, we have a sad face parabola. And that's that. All right. Well, that's it for that one, and hopefully that was helpful, and we'll see you guys later.